Good afternoon. This is Wei-Tek Tsai speaking. I'm currently in Beijing. Today is January 24th, around 6 o'clock Beijing time. And I'd like to share with you some of the technology we have been working on for the last 3 years. We started the blockchain research and development in 2015. And that was before the IBM announced the Hyperledger project. And that was before the term permissioned or consortium blockchain was coined. In fact, I had the discussion, and then the very next day, then Vitalik published a blog about the consortium blockchain, and that was right after my meeting with him. And that time we talked about how we can design permissioned blockchain for enterprise computing. Anyway, so the thing is this: if we look at the blockchain, we can divide the blockchain into public blockchain, or permissioned blockchain, or private blockchain. And so we are over here. And because our goal is for enterprise applications. And when we look at this, if we look at this, one of the things is the consensus protocol. And a lot of people talk about PBFT. Okay, that's the Byzantine protocols. So in July 2015, when I assembled my people to actually design a new blockchain. And at that time, we already look at the Ethereum and all these things. But after a lot of thinking, we decided to start the blockchain from scratch. And because there are literally only about 5% of the code that can be reused from the Ethereum. Anyway, so we start using the PBFT, but then immediately when we started the PBFT, we run it. We still remember the first prototype we run is about 1 minute. We run about 200 transactions. So we will say, wow, that's amazing. That's so slow. So anyway, so we continue to work on, and then gradually we came to the idea called CBFT. And the idea of the CBFT is that each of the block can be folded concurrently. And if we take a look at these Byzantine protocols, you will design so that it will be executed sequentially. And if you execute these things sequentially, it will be very difficult to have double spending problems, and then there will be a lot of problems can be easily solved. However, the performance will be very low. Okay, so we find out actually when we look at the consensus, we are breaking from traditional database or from traditional consensus paradigm, because right now we have a block, and block has different transactions, multiple transactions. You can have 1, you can have 2, or you can have 1,000, and some of the blockchain can have 50,000 or 100,000 transactions in there. And then when you have all these transactions within a block, they are voted at the same time. Therefore, this is and we have created a new consensus paradigm. And this was not well discussed in the literature, because people in the good old days, they do consensus one by one, each of the transactions by one. But when we deal with a block, we are suddenly in a different paradigm, because we are voting, say, suppose each block has 1,000 transactions. So we are handling consensus of 1,000 transactions at a time. And not only that, we need to have link them together in a linked list. And once they are linked, they cannot be changed. So this creates a very challenging environment. And we just find out something interesting. Once a block has been formed, then the voting itself can be concurrently done. And there's where it is of first significant breakthrough. is that we will let the voting to be done, and we decide that things can be, we just decide the order ahead of time. And once we do that, we can do a pipelining functions, and we can do this, these things. And people say, well, how do you worry about the double spending? Because right now, we are voting on a block. Okay, we are voting on a block, and then we handle the these double spending within the block and between the block, outside of these consensus protocols. So we can handle these things outside. So we need about 2 separate mechanisms. So this is something that we spend a lot of time, and people have thought we should handle the double spending and consensus together. But these are 2 separate mechanisms. And then also the consensus that we are dealing with. We are dealing with the block consensus. We're not doing individual transaction consensus. Therefore, the protocol that we can decide can be different from traditional consensus protocol. So that's the first thing that we do. We find out we can do this concurrently, and we can handle double spending as additional mechanisms, and that's what we do. And then you say, how far we have done? Well, we can talk about this. So these are the first technology that we actually developed. And another thing which we developed, when we look at the blockchain, the traditional blockchain, we found out it's very interesting. Because a traditional blockchain like Ethereum or Bitcoin, what does it do? It stores the transactions. It does the trading, mean the payment, and then you store the account value or the UTXO. So it really does is that it handles the trade, and second, it does the account management. And I've been a professor of computer science and actually a software engineering professor for over 30 years in the United States. And in one of the principles, or fundamental principles of software engineering, each software module only handles one function. That's something that I talk to my students for over 30 years. I've been a professor for 30 years. And then when we look at this, we find out you handle 2 things. So we say, why don't I split this? So this I call TBC. This I call ABC. Okay. I have a blockchain that handles the transaction. I have a blockchain that handles the account. Once we divide, it has very similar design, but then it just does one function only. And what we found that once we divide the functionality of a blockchain into 2, then each of the blockchain can be optimized easily. For example, like ABC, we can easily do the sharding, and each of the shards will have no interaction with other shards at all. So we can do the unlimited number of scaling, and because of this, the TBC can be smaller. So this is something that we actually did. And we eventually call this ABC, TBC architecture, or later we call Panda model. Okay, so this is something that we actually did. And then sometime happened in last year. There are 2 companies, they contact me, and they say they are interested in the clearing. During the 2016 and 2017, a lot of blockchain companies start doing the trade cleaning, and a lot of people doing the payment. And we're not talking about digital currency payment or something. We're talking about enterprise level. We want high speed. Okay, we really want a high speed. Okay, and one of the things is that once you divide these things, what happens? We find out if we can do divide and conquer, then we can use multiple processors to handle these things, to speed up the process. That's where we have done. And then there's two independent companies. They came to talk to us. One of them say, why don't you try for trade cleaning? If you have a trade, can you clear it? Can you do it? So we spent 3 months and just to understand the requirement. And then we spent just 1 month. We developed a blockchain with the big data. So instead of a traditional blockchain like this, say I just write 4 nodes. Right now, each of the nodes can be a big data. Okay, there could be multiple nodes. Okay. And guess what happened? Once we do this, then we can process very large amount of data rapidly, because each of this, if it's an ABC, it can be shared indefinitely. I mean, whatever thing we can do unlimited scalability. So this is something that, so we take our design, we implement this, and we try in the actual cleaning center. They give us our historical data. We run it through. We actually run over 3 billion transactions. And that is about 16 years of London Stock Exchange data. And that was the biggest blockchain experiment that we know. We talked to many high-tech companies in the United States, in Europe, and in China. And I asked them how much data they have tried. None of them had done the size and scale of our experiment. Okay, maybe they do 1,000 transactions or 100,000 transactions or millions of transactions. But what we did billions of transactions. Okay, we did billion transactions, and there is no double spending problem. There is no problem we encounter. And what is interesting thing is, we didn't know that the clearing center, while they allow us to do experiment, they actually test our software in the darkness. They didn't tell us they are actually reading our report or the clearing result from our system. They actually compare to their existing system to see whether we make any mistake. And then after checking all the data, billions of transactions, one day when we met them, they say, you know, we have checked all your data, so far 100% correct. And that's an amazing statement, because we went through billions of transactions. And then after we try that billions of transactions, we actually do a real-time transactions. And when we do a real transaction, people say, when you do real-time transaction, things will be much tougher. Actually, opposite is true, because the real-time transaction is about 1 million trade, or maybe, sorry, it's about 1 million trade per month. And actually our system just went through easily, because we have processed billions of transactions about in 20 days. And in 20 days, in real time, we only need to process 1 million transactions or so. Therefore, this is, we handle this. And then at the same time, another company came and see us, say, can you do payment? And they're not talking about payment in Ethereum, payment in Bitcoin. They are talking about Visa type of payment. Okay, this is, you know, the Chinese has the largest third-party payment systems. And but each of the payment require a lot of checking. Oh, by the way, each of the trade in the clearing system have to access 6 accounts. Okay, so, and in the payment, a lot of things have to be verified before a payment can go through. And there's a lot of interesting things that we have to walk through. For example, each of the payment must be done within a second hopefully within 0.5 seconds. Okay, I know there are some blockchains. Okay, you may take hours to do a confirmation, and there are some fast, efficient blockchain. They may take about 10 minutes or 10 seconds to settle. But our requirement is to settle that within 0.5 or 1 second. So when we look at this, then we find something interesting. The payment systems that we have to do, the blockchain design, is fundamentally different from the clearing centers. So we have to spend a lot of time redesign. So it's not just one size fits all. This is suppose we know we have IBM, have Nigeria, we have many blockchains, but that is one site. Okay, that's just one site. But when we look at the payment world, when we look at the clearing world, they just have fundamentally different architecture. So the consensus are still there, all the database are still there, but then the algorithms and structure are very, very different. So we actually restructured our system, and we spent almost a year working on this payment systems, so that each of this the payment can be completed within a second. It's about 0.5, and this is something that we actually did it, and then so this is the clearing center. We actually settle each of the trades settle about maybe 10 to 20 seconds, but this fundamentally, but this is a huge size. This is humongous. Okay, this is something that humongous things, and not only that, because this thing here, they can actually do the regulation checking and compliance within the big data behind it. So this is something that has very significant implications to regulations, compliance, checking. Okay, the AML, KYC, all these things. And same thing here, we can do similar things on these. Anyway, so these are the things that we actually do. And we spent the whole year, we spent the first part of 2017 to develop the system, and we spent the second half of 2017 to optimize this, because this is the first time a big data is merged with the blockchain. So there's a lot of fundamental changes. And without telling the world, we're also working on the payment system behind the scene. And this architecture and things are very different from that. So we actually have two fundamental designs of a blockchain. And each has a database, each has a consensus, each has encryption and hashing, all these things. But other than that, they have very different architectures, and they have very different performance, and then they have very different design in many ways. Anyway, so these are the two large applications that we have been working actually mostly in 2017. And during this process, we also find very interesting. Remember this, if we break the blockchain into two blockchains, ABC and TBC, then we found something very interesting. Say we have a bank. Say we have a bank here, and we have an exchange, and then we have a clearing center. And what happens is that each of them can be an ABC. And then it can have a TBC. Link these three together, or it could be other TBCs. And if we do this, then we find out all these organizations can keep their data in confidence while they expose the data. So they only need to expose data when they have to. Otherwise, they can keep their data in confidence. And then we can have many exchanges. And we can have many banks. And suddenly, we are creating an internet of blockchains. And with this internet blockchains, so we can have multiple ABCs, TBCs, and multiple ABCs. So suddenly we can have a web of blockchains, each protecting the data, to keep the data in private, allow this exchange. At the same time, we can have regulated agencies. See, and regulated agencies can have a node in here. Then the regulator can see everything, and they can monitor the process. So suddenly, we have a web or internet of blockchain. I can do a lot of things that are not possible before. And all of them are blockchains. All of them have consensus, all of them have encryption, and all of them have hashing, all of them have a database. But they can do things, they can do a lot of things. So these are just some brief things that we do. We also have other things, but I think I probably spend more time, and maybe next time I will talk about sandbox that we do. So we actually do a lot of things in depth, and we work with these companies for a long time, and we have developed technology, and we actually deploy some of the things in real environment, and they test and run it. Okay, so thank you for your attention. If you have any questions, maybe you can find a way we can communicate. So thank you very much. Thank you.